Hello and welcome to another video in the Query Stuff series. Those of you that have watched some of my other videos know I'm a really big fan of the lists and record functions available in Power Query Editor in M. And this is another example of the cool stuff you can do with those. If you like these videos, please follow me on Twitter or subscribe to this Hoosier BI channel so that you see the latest videos that we put out. All right, and so in this one, we're going to use custom list and record functions to do data transformation in the examples I'll show today, significantly faster way, but at least you can do custom and maybe get to your desired data transformation in a single step. All right, so let's jump over to the query editor. And before I do that, before I jump into the examples, I'll just do a simple query just to demonstrate what I mean by custom list and record functions. So I'm just going to make a quick table here, ABC. And the first thing I'm going to do is add a custom column with a list in it, just so you can see why we're going down this road. So if I add a custom column, and if you've been starting to learn M, you know that lists are the things in the curly brackets. So if I just make a list 1, 2, 3 here inside of curly brackets, that tells M that this is a list of 3 numbers. I hit OK, and so a list shows up in the column there. You can see it by clicking to the right of the list. You could drill down by clicking onto it. And so the nice feature about lists is you get this expand button up here. So if I hit that, I can go expand to new rows. Okay, and so for each value in column 1, there's now 3 rows for each of the list values. All right, so that's a cool feature of lists, that expand to new rows feature that we're going to take advantage of. And so now for an example of a record function, records are in square brackets. And so if I go new category equals A, and I'll put a second field there, department equals B, for example. Oops. End it with square brackets, and so now this is a record syntax, and so I hit OK. I see a record on each row, and again I can preview the contents and I see my category and department. And if I hit the expand button, you can see that now I could expand these 2 fields and turn them into columns. Okay, so that's just a quick intro to custom lists and columns. And the thing we'll take advantage of here is in these examples I typed in values, but you can actually use the fields from your query tables to populate lists and records to get your desired result. So one more thing I want to show about these is if I insert a step after this, it'll reference the previous step, this expanded custom 1. And so if you reference just a single column, in this case I'll just reference single column 1, and you put it in square brackets, this is a column syntax, and if I hit OK, I'm going to get the values of column 1 as a list. Okay, and so that'll come in handy with one of the functions we're going to show today. So let me get rid of that. And then one more thing is if I add another custom column and I simply put an underscore. Okay, and what this is shorthand in M for the current record. And if I hit OK on this, you'll see that I get a record, and what's inside this record is all the values of the columns on this row, right? So that's a really handy way to just quickly get to all the record values for the given row. All right, and so we're going to use all those things I just showed you in the custom functions. So I've got 2 examples to show today where you can apply what I just talked about to sort of standard patterns that are out there. So the first one I'll show you I refer to as repeating rows. And so you may come across data in this format, whether it's from a database or you've combined a bunch of Excel files, or it doesn't matter the source. But if you've got data here where there's really, each sort of record is distributed among 3 rows here, and there's, again, pretend these are names, I just put numbers by them, but you've got employee 1 that works in department 1 and reports to supervisor 1, and then you've got the info about employee 2, 3, 4, and 5. And I've made this table so that later when we check speed, I can quickly expand this to lots more, but for now I just kept it to the data for 5 employees, so there's 15 rows, but we'll make it much bigger later when we go to test the speed. Typically how you would handle data in this structure, which is a perfectly fine way to do it, but what I'll show is going to be a little faster, is to use this approach. So for each of these example queries, they start by referencing this first one, so they're all using the same source data. So later when I make this table much bigger, these will still point to that bigger table, and we can compare how fast they are. And so in this case, you'd start with that same source table, and a common approach would be to add an index column. And what we really want to end up with is the 3 columns for employee, department, and supervisor, and each employee on its own row. So 5 rows with the data split out into those 3 columns. So we add an index column so that we can do some math on it. You would insert a modulo column, so you're dividing it by 3 and then taking the remainder basically. And so you get a repeating pattern of 1, 2, 0 is the way this works out, but it doesn't matter as long as the data of the same type, and so on the values, the rows with 1, you get the employee name, department names are on where the value equals 2, and the supervisor's in 0. And then you could do the similar thing with the index column, divide it by 3, round those values up, and now we've got a repeating series of numbers 1 through 5, but repeating in triples there, so that the index column now would be, this is row 1, this is row 2, all down through 5, and then this gives you your column information. And so from this standpoint, we can use the pivot column step and split the data out. And so now we're in our desired final format. I just have to rename the columns, and I get the data I was hoping to get out of that starting structure. Okay, so that's how you would typically handle it. So let's talk about 2 ways that you could transform the data to get the same result using list or record stuff. And this first one I'll show you is basically trying to get you straight to this step right before the pivot, but in a more direct way. All right, so I call it just using list repeat. So in this case, and you can see that there's fewer steps here. If we go same source step, and then we go to this step here, list repeat, you can see I know what my final column names are going to be, so I could actually hand enter a list of those values, employee, department, and supervisor, and then I can say, hey, make a list where those values just keep repeating. And this second term of list.repeat is how many times to do it. And I told you before there were 15 rows, so if I do table.rowcount function of the source, I'd have 15 divided by 3, so it would repeat these 3 values 5 times, which is what we see here. Okay. And so then what we can do is a similar thing for getting our 1, 1, 1, 2, 2, 2, 3, 3, 3, and that's using this part of this function here, where I would do a similar thing, where I would basically do list repeat, and this time I'd calculate I want to go a list from number 1 to number 5 because our row count is 15 divided by 3. So make a list from 1 to 5 and repeat that list 3 times, so we get to 15 rows, and then I wrap that in a list.sort so that the 1s stay together and the 2s and the 3s. And so then I've got that new list we just talked about, the list from the previous step, list.repeat, and as I mentioned before, if you just reference a table and put the column name in square brackets after it, you get the values of that column as a list. So these are 3 lists, and then you can use this handy function called table.fromColumns, and this takes lists as so you give it a list of lists, and then it'll just put them together and create a table out of them. So I'm taking these 3 lists and making a table out of them. And so then all that's left is the pivot column step, and I've got my results without having to rename the columns. So that's a faster way to do that, and we'll prove that when we expand this out. The last way I'll show you, and this is actually the fastest way to do it that I found, is, again, you start with the same source step, okay, and then in a single step we have this custom step here. And reading these M functions, it's easiest just to go from the inside out. So if you look, I'm going, okay, source data, which will give me a list of those values from the data column. Then I can split that list into lists of three items long. So it's taking those 15 values and making 5 sublists, each with 3 values. And then for each of those lists, I wrap this in list.transform, and I want to change each list. And then so for each of those 5 lists with 3 values each, there's another function called record.fromList. And the underscore in this case just means the current list you're iterating over. And it's saying, hey, take the values, those 3 values in the list you're iterating over, and convert it into a record, and call those 3 record fields employee, department, and supervisor. Okay, so there's a lot going on in that one, but you can see what each record looks like by clicking on the right, and you can see that it works to, again, take that original list of 15 values, make 5 lists of 3 values each, and then convert each of those lists to a record with these field names. Okay, so again, you can download this file if you want to look at this more closely. I'll put the link in the description. And then from there, we can just convert this list of records into a table. And then from there, it's easy. We just do the expand button and change our data types, and we've got our values there. So just to show you that this approach is faster, let's go ahead and we'll crank up the source table to be bigger. And right now it's set to 5. I'm going to set this to 200,000. So this will create a source table with 600,000 rows, and we want to pivot it out that way. And so what I can do is all 4 of these are loaded. So when I hit close and apply, we'll basically see all 4 of these tables get generated. And so this source table you'll see complete first, because that's one that feeds all those other 3, and then you'll be able to directly compare how fast these 3 are. So let's hit close and apply, and then we'll be off to the races. And just by how quickly they get to the 200,000 rows, which is how many rows it should have, 600,000 rows with repeating every 3 values, and then we end up pivoting that, it should be 200,000. So our source is 600,000 rows. You see this one's already done. This one is quite a bit slower, but still faster than the traditional way of doing this. And so that one's finally there at 200,000. And then bringing up the rear is how this is typically done. And so you can see that doing the custom list of records is quite a bit faster than the traditional way of handling this. Okay, now let's do our second example. So we'll go back over to the query editor, and we'll now talk about this one up here, where I did a similar thing where I have a source table that has this pattern of repeating columns. So what I mean by that is, we've got these product numbers here, and then we have these pairs of columns that have like a report date and a number of items sold, right? But it's these 2 go together and these 2 go together, and then there's a third set out here, right? And so this is the pattern we're trying to address is, how do we transform this table into a more analysis-friendly format? And so again, I'll quickly run through the traditional way of doing this type of pattern is, you would start with an unpivot. So again, we start with our source table that has the 3 sets of repeating columns. We'd start out with an unpivot step. In this case, and you would see variations on this, but we've got most of the information there, but they have differences in what's at the end. So in this case, and your case would likely be different, I'm just doing a extracted text before delimiter and just taking the stuff before the period. So now I have these repeating values here of report date and sold. And similar to the previous example, right, we're going to start doing stuff with an index column. So in this case, I add an index column starting from 1. I divide that by 2, and then I do a roundup step. And similar to before, right, I've now associated these top 2 rows are going to be row 1 in my once I pivot, pairs of 2s, 3s, 4s, etc. So then we do the pivot step, and then I can get rid of the index column. And so then this is a good analyzable format that I could then load to my model, connect it to a date table, and make my reports. All right, and so if we approach this way with custom lists and records, there's 2 ways here, and number 3 ends up being the fastest, but it's directly hard-coded. And then I have another version that shows you how to do it. If I, instead of having just 3 pairs of columns, what if I had 50 pairs of columns and I needed to deal with that? So this is a little bit slower, but it fully automates that, so you don't have to hand code all the columns. So let's go through the hard-coded one first. And a lot of the magic just happens right in this next step, where we start with that same source table. I add this custom column, and in this, you from what we talked about before with lists and records, you can see what I'm doing here is for each row, I just added a custom column, and for each row, I start with curly brackets, so I'm creating a list, and then inside of that list, I'm creating 3 records, right? So this is a list of 3 records, and I'm just using my column names to say, and so I have the first field called report date, and I grab the report date column right here. And then my sold equals the sold column. And then in the second record, I have the same field names as the first one, report date, and then I use report date 1. Sold is sold.1, and the same thing for the third record. Okay, so really straightforward. I just hand typed it in, but I get to once I do that step, I add this column here, and again, I generated a list of 3 records. So if I click to the right over here to get the preview, I have a list of 3 records. And if I were to drill down to that list, I could then preview those records, and you would see that it's these pairs of values that were taken there. So from that point, I can remove all that stuff because I really still just need that first column with product number, and all the other columns I've now restructured into this list of records that I can then expand to new rows, and that's what I did in this step, right? And then from once the list of 3 records is expanded, so now I've got 3 rows each with 1 record each, I can then hit this, and the 2 fields that I created called report date and sold are right there, and I can expand those. And of course, that's what I did right here. I changed my type, and I've got the data as I wanted it, right? And it looks just the same as how I ended up in the unpivot index step. Okay, so now let's talk about this last example. And as I mentioned before, let's say instead of 3 pairs of columns, you've got 50 pairs of columns, and you don't want to hand type out 50 sets of column names there. So in this case, we start with the same source, and maybe I won't go through this in too much detail, and you can download the file if you want to look at this more closely. But remember, I showed before that if you add a custom column and simply put the underscore, you get a record of everything on that row. And there's this function here called record.fieldValues, and what that does is it returns as a list all of the values inside those records without the field names. And so I can then, because I've got my product number here, I don't need those values. I'm going to keep, I'm not going to remove those later. I can get rid of the first one, and then I can do list.split, and I say I want to break up this list of values into sets of 2, sublists of 2 values, right? And so if I had 50 pairs of columns like that, I'd take the first one off, and then it would be 50 lists of 2 values each. And then similar to what we did before, I can do a list.transform on that list of 50 smaller lists of 2 values each, and from each turn each of those lists into a record and give the field values for that list report date and sales. And so when I do that, right, I get my list of records just like before. In the case where you had 50, this would be a list of 50 records if you had 50 pairs of columns. And so similar to before, I can remove other columns, then expand the record, change the types, and I've got the final table just like the other queries. And I think the original one was, I don't know, 8 steps. This one was 6. This one was also 6. It's not just the number of steps, of course, it's what you do in the steps that matters, but fewer steps is better if you can consolidate things and do more things in one step. So again, we can go to our original table and I can turn this up. It's from 3 values, and from playing with this earlier, I know 20,000 is a reasonable number to show the difference. All right, so those all have the same source table, much bigger. And if I enable load on each of these, we can be off to the races again. All right, so now I'll close and apply. Because we didn't change these, they'll stay loaded, but we won't see them refresh, but we will see the new 4 tables refresh. And again, you'll see the source table load first, and then you'll see this list records hard-coded come in the fastest, and then this one is still faster, and then the unpivot index, the traditional way of doing this kind of transform, comes in last. So you see these two are already done, 180,000 rows each. And now that one's finally done. All right, so again, all the tables are the same, but the refresh rate is much faster. So if you have even bigger tables, that difference would be more pronounced. And again, this may give you some ideas of how to just hard code in or use lists and record functions to directly do your data transformation in a single step. So hopefully you picked up a couple of things from this and will consider using this. Even if you don't face those specific data patterns, you might be able to use it in whatever data pattern you're facing. All right. So again, please subscribe to me on this Who's Your BI YouTube channel, or follow me on Twitter. Thank you.